Hello and welcome back. I'm Adam with Push the Envelope, the channel that gives you everything artificial intelligence and machine learning. Welcome to part 2 of our Titanic Dataset Machine Learning for Beginners series. Now, in the last video, we went ahead and filled in all of the missing values and started taking a look at what the values are within those data frames. If you did not see that video, go ahead and check that out. I will link it up here, and you can go ahead and click on that and get caught up. I'm going to be starting where we left off. So again, if you haven't seen that video, you may be a little behind. But let's go ahead and start looking at how we can further process our features to get them ready to be fed into our machine learning models. Okay, swapping over to the Jupyter Notebook, you can see we are starting right where we left off in the last video. Again, if you haven't seen that video, go ahead and check that out, get to the same point. But we have our data frame here that has all of the missing values filled in, and we are ready to start looking at what some of these values are within each of the columns and how we can kind of further process them to make it a little easier to create a model. So first one we are going to look at, actually, let's just go ahead and print all of the different within each column. There's a whole bunch of unique values. So for instance, this class value or class column should have 3 unique values, 1, 2, and 3. But some of these other ones, like the name, is obviously different for a lot of the different passengers. So we need to either remove those columns or we need to process them so that we don't have a one-to-one mapping between what the passenger ID was and what the feature is, because the model is going to overfit or just not find it useful at all. So to do that, let's go ahead and print combined pd dot n unique unique. All right, n unique is number of unique. So for each column, it's going to print the number of unique values. And okay, running that, you can see there are 1,309 unique passenger IDs. Well, that is obvious. Every single passenger was given a unique ID. Now, I'm not going to do anything to process this because when I pass it to the model, I'm just going to completely get rid of this column because it serves no point at all. So let's look at some of the other ones. P class, again, that is what we're looking for. So the classes are first, second, and third. There are only 3 values here. And if I just go ahead and print combined pd at p class dot unique, you can see those are 1, 2, and 3. Exactly what we want. Don't need to worry about processing that any further. Now, things like the name, where we have all but 2 that are unique, we are going to need to process that. We could either drop the column because it doesn't serve a purpose, or what's probably better is to just go through and take apart this name and get the information that is useful to us. So let's go ahead and start with that. I'm going to say, I'm going to take this where we printed the unique classes. I'm just going to do the same exact thing for the names. Okay, so you can see we have a giant list of all the different names. Now, what I care about is the ordering of each of these names. So we mentioned this when we first printed the data frame, but each name has the last name, comma, title, first name, middle name, and then if they have any nicknames or anything like that. So useful things would be, maybe I want to know what the last name, the title, and the first name are. And so we can go ahead and just process all of the strings within the data frame in order to extract all 3 of those. So let's go ahead and do that, making a new variable called names. And I'm just going to extract the name column. And 3 things I want. I want the last names, I want the titles, and I want the first names of each of the individual passengers. And we're going to go ahead and just create a for loop. So for name in names. So I'm going to just iterate through all the names that I just extracted. And I'm going to start breaking them down. So the first thing is the last name. So it's a last name and then followed by a comma. So if I can just split the string on this first column or first comma, then whatever comes at the beginning is going to be equal to the last name, and whatever's after it is just going to be the rest of the name. So I need to make sure though that if this comma doesn't exist, then I don't want to split the string because there's just no last name on file. So I just want to first make sure that the comma is in each of the names. So to do that, I'm just going to check if the comma is not in the name, then I just need to append nothing to the last names. So last names.append, I'm just going to do a blank string. But if it is in there, I'm going to say last in name. So I'm going to make two variables. I'm going to say the last name and then the name. So just the remaining name is going to be equal to name.split. And we are going to be splitting on the comma in the space. So a comma followed by a space is where we're going to split. Now, it's possible that there are more than one instances of a comma. So I am going to say I only want the first split that happens. Only split it once. If there's a comma after that, don't worry about it. Okay, so this is going to give me the last name saved here, and it's going to give me the rest of the name saved in name. So I can actually just go ahead and straight up append last to last names, and that's going to store all of my last names, and we're going to continue on with name. Okay, that takes care of last name. Now let's look at how to get the title next. Again, the title is a dot followed by a space, even for the ones that aren't an abbreviation. So like you can see master and then a dot. So we're going to do the same thing up here. Actually, we can just go ahead and copy this. But I'm going to say if the dot is not in the name, then append a blank string to titles. But if it is in the name, now we can start processing it as title, and the remaining part is going to be the first name. So it's going to split at the dot here. The left hand side is going to be the title, the right hand side is going to be the first name. We're going to do a name.split at that decimal, and I only want, again, the first one because, for instance, the middle initial may have a dot after it if there's something else within it. So I only want the first instance of the period. Let me just get rid of this one. So we're going to do titles.append title. And we are going to do first names.append first. Okay. I'm just going to convert all of those different lists I made to NumPy arrays because they're easier to iterate through. np.array, and I'm just going to pass in that list that we just did. I'm going to copy this twice. Once for titles. And one more for the first names. Okay, so we extracted all of our last titles and first names, and we converted them to NumPy arrays. Let us go ahead and start looking at the titles. So I'm going to print titles. Let's do value counts. Oh, sorry. We're not working with pandas here. I want to know the. Let me start over. I want to know np.unique titles. This is going to just give me all of the unique values for titles. Now, this is only going to give me the unique titles. I also want to know how many are in each of those different titles. And so I can pass a second, in this np.unique, I can pass a second parameter called return counts and set that equal to true. So that's going to return the counts back to us. I'll go ahead and print that. All right. And let me just print a divider so that we can actually see what we're looking at. Okay, so you can see we have Captain, Colonel, Don, Donna, Doctor, a whole bunch of other different ones. But you can see there are a lot of just one-off values. So we want to kind of group these a little better. Now I'm seeing a lot of captain, colonel, major. Um, there may be some other ones in here, but a lot of military titles. So that could be one column is military. I'm also seeing a lot of misses. Sorry, misses, and misters. So we can group a whole bunch of those. And then I'm just seeing a whole bunch of random. I'm actually seeing a lot of like nobility, maybe. So ladies or sirs or countess. So we can group those. And the last one will just kind of be, if we have any left over, a miscellaneous, just random other titles like reverend or whatever else we can come up with. So let us go ahead and start combining some of those. So I need to find the indices of the ones that we're looking for. So I'm gonna say np.where. I want to know where np.isin. So I'm going to be passing in a list of different titles. I want to know all the indices where the titles is in that list. So I'm going to be passing in the titles array that we just created. Now I want to know where the titles is equal to all of those military titles. So let's call those, or let's just call each of them out. So that would be captain, colonel, major. That may be it. Yeah, it looks like that's all of the military titles. So all this is doing, looking for when the titles is equal to any of these um, different titles right here. And that is good. Now I want to say, I'm going to take the titles. I want to say add those indices that we just found. I want to set them all to be equal to, um, let's come up with some name for it. So let's just call it military. So it's just replacing captain, colonels, and majors with just the military title. I'm going to take our unique function. I'm just going to move it down so that we can see the changes. Okay, so you can see those were removed. Now we have this military column. And we can just continue doing this for all the ones that we want to group together. So I'm going to copy what we just did. And now let's look at the like the nobility category, because that seems to be a lot of them. So if you look up some of these, you can tell whether they are, if you haven't heard of them before, like Don, Donna, some of the other ones, Mademoiselle, a lot of them, you need to look them up and figure out, which country they originated from, whether that's a sign of nobility or maybe it just means Mrs. in English. So I went ahead and looked up a bunch of those. So I came up with a list. Don is in there. Donna is in the nobility category. The junk here. Lady. Sir. Master. And the Countess. Countess. Okay, so all of these are kind of like the nobility titles. And this actually will group a lot of these one-offs together, so that helps us a lot. And we are going to call this nobility. Go ahead and run that. Okay, now you can see our list is much shorter now, and we have this nobility column, and it has 67 people in it. So that's great, but we still have more that we can combine. So next, let's look at what other ones do we have that are just like ones or twos. So whatever the fourth one is. So Mademoiselle, that's MLLE, and Madam are right here. So these are two that we need to figure out where to put them. Well, let's start with Mademoiselle. Again, I'm going to copy what we did for the ones up here, but I'm going to get rid of all the ones we were looking at before. Now, starting with Mademoiselle. Mademoiselle is just Miss in English. And as you can see, there's also Miss spelled out and MS. So let's combine all three of those. So we're going to take Miss, we're going to take Mademoiselle, and we are going to take MS. We're just going to combine all of those to be, let's just do shorthand Miss. Okay. List continues to shrink. Now, same thing, Madam, that refers to Mrs. So we can do the same thing. And that would be, there should be only be two. So it should be MRS and MME for Madam. We're going to set those to MRS. Okay, now our distributions are looking a little better. We still have Doctor and Reverend, but they do each have 8. So I'm actually just going to keep that. You can see there are a lot of Misters, and then not as many, but quite a few Misses and Misses and Miss. So this is actually as far as I'm going to go for kind of grouping those together. That it puts us at 1, 2, 3, 4, 5, 6, 7 columns or 7 categories. So that's fairly good. And now the last thing we need to do is we just need to go combined PD, and we are going to be replacing the titles. And we're just going to replace it with titles because titles. There we go. Okay, we're just going to replace the titles with the new ones that we just created. And if I display combined PD, we should see that we now have a titles category. Okay, that takes care of the titles. We also extracted the last names and the first names. For now, I'm actually just not even going to worry about those. I'm going to keep them as a variable if we want to come back and do something with them. But that is all I'm planning on doing for the name category. All right, coming back up to look at our unique values. Took care of the name. The sex is 2, that's fine. The age is 98. Now we need to get the age to be something that's a little more usable. And it's going to be back to trying to bin the ages into different categories. So I want to know print combined PD at age. I want to know what the minimum age is. And I also want to know combined PD at age dot max. I want to know what the max and mins are just to see what we're dealing with. And as you can see, we have pretty much a newborn here. And then we have an 80-year-old. So those are our min and max values. And so I'm going to consider this to be 0 to 80. And so we can come up with bins maybe every 10 years. And that will give us 8 bins, 9 bins. Should be 9 bins, I think. To do that, we're going to define bins. That is going to be equal to a numpy array. And this is where we throw our bins in. So 0, 10, 20, 30, 40, 50, 60, 70, and 80. And the cool thing about pandas is pandas will actually just take care of all of this for us. So it's going to be combined PD. We're going to make a new column called age underscore bin. Let me just capitalize that. All right, so we call the age bin. And age bin is going to be equal to pd.cut. So the cut function is just going to cut all the ages and put them into these different bins. We need to pass it combined PD at age. And we need to combine it the bins that we just created. So again, this is just taking the age and binning all of them based on the values that we set for the max size of the bins. Let's go ahead and display combined PD. Okay. Now you can see we have a new column and it has these intervals for all the different ages, which is exactly what we want. So if you take age 22, that falls within the 20 to 30 bucket, exactly where it should be. Age 38 falls between 30 and 40. So just a way to cut it. I'm going to leave it at intervals of 10. We may need to come back and mess with those intervals to maybe get some better performance. But for now, that is what we are going to go with. All right. Continuing on. Okay, so number of siblings and number of parents, those are just integer counts. For now, we'll leave those. We'll come back to them, though, and figure out something else to do with them. Tickets, 929. We definitely need to figure out what to do with those. Like I said before, if the tickets are the same, that means that they were purchased together. So we need to take... we don't necessarily care the ticket number because it doesn't tell us too much. But what we do want to know is the ones that were purchased together. We need to use that in order to adjust our fare, because our fare is going to be based on however many tickets were bought with that ticket number. Okay. I am actually going to make a dictionary to hold this. And I want the dictionary to have the ticket number as the key, and it's going to pass us how many of those ticket numbers are within the data frame. To do that, I'm going to make ticket dict. That is going to be equal to a dictionary of combined PD at ticket dot value counts. Again, if you remember, value counts gives us the ticket number as the indice, and it will give us the number of those tickets as the other variable in the column. This is going to create a dictionary. I just print it out with the ticket name as the key and the count of the number of tickets with that name as the value. Okay, that gets us halfway there. Now we need to say combined PD. I'm going to make a new column called ticket underscore count to just temporarily hold each of those ticket counts. I'm going to set that column equal to combined PD at ticket. I'm going to take the ticket column and I'm going to dot map. So I'm going to map a dictionary to it. So that dictionary that we just created. So I'm taking the ticket count, using those as my keys to pass in the dictionary, and saving the results as the ticket count column. I'm going to display combined PD just to show you. Again, we have this new column called ticket counts that is storing all of the instances of that specific ticket number in there. Okay, now that we have that, we can go ahead and adjust the fare. So now we need to adjust the fare to be the fare per ticket. I'm going to make a column called combined PD at again, fare underscore per underscore ticket. And I spelled fare wrong. Let me go ahead and correct that. All right, so fare per ticket, I'm going to set that equal to combined PD at fare. Take the fare column, divide it by the one that we just created. Combined PD at ticket underscore count. Taking the fare, dividing it by the count. If only one was purchased, then it's going to keep the fare the same, but if more, it's going to adjust that. Let me just display the data frame. All right, now we have an adjusted fare per ticket, which is what we want. So we have taken care of the ticket column and the original fare column now. Now, the problem is, just like the ages before, we have a ton of different unique variables or unique numbers stored for the fare per ticket. So we're going to need to do a binning like we did before. Let me just make some room in here. I'm actually just going to show kind of the distributions of all the different fare prices. So I can do a combined PD at that column that we just created, fare per ticket. This is going to be dot value underscore counts. I want to take the index values. So index dot values. Again, this is just the unique fare prices passing in as X. I'm going to copy this, and I just want the value counts for the Y. I'm going to do a plt.show. Okay, now you can see our distribution. We have a lot of them in this range, and then we have some outliers that are way out here at past 120. If I go ahead and print combine PD at fare per ticket dot min, I'm gonna take the same thing, do these for at max. Okay, you can see that our tickets range from $0 to $128. That's a fairly big spread, and there seems to be a lot of outliers out here. And we'll take care of that with our binning. So let's go ahead and basically do what we did before. Create a bins variable. This is going to be equal to, for the most part, probably bins of 10 would get us most of the way there. And then obviously as we get out here, there's a big difference. So we'll adjust for that. So we'll go, actually, let's do bins of 20 maybe to capture like this big one, this big spike, and then we can work our way out. So I'll do 0, 20, 40, 60, 80, and then I just want to capture everything past 80. So all the way out to 150. Okay, let me just get rid of some spaces, clean it up a little bit. All right, so that is just these two outliers out here. We're just gonna put them into our final category as over 80. But everything else is gonna be binned in categories of 20. Again, we can go back and change this if we find that maybe this wasn't working. Maybe we can reduce our bin size or do something else. But for now, we will go ahead and do this like we did the last time. We can do a combined PD at, I'm going to make a new column called fare underscore bin. Fare bin is going to be equal to pd.cut. If you remember, cut was how we cut each of the variables into the different bins. We're going to do a combined pd at fare per ticket. So we're going to take all of the fares per ticket, and we are going to take the bins and also pass those in. So cutting all the fares per tickets into their specific bins, and go ahead and run that. Now, again, just like the age bins, now we have a fare bin that is passing however much they paid for. So if I go ahead and find the fare column, paid $7, that's between 0 and 20. So that's where it's going to be thrown in. Okay. Now, I think we've taken care of most of the columns except for the number of siblings and number of parents. So I could leave these as separate columns, and maybe I will, but I would also like to combine both of these just to create another column that says how many family members do you have on board with you. And that should be fairly easy to do. Just by saying combined PD, I'm going to call this num family, or number of family members. That is going to be equal to combined PD at sib sp, siblings and spouses, plus the combined PD at parents and children. And I'm just going to do a +1 to include that person as well. So just the family size, including the person that is traveling. Let me display the data frame to see the changes. All right, easy enough. Now we have a number of family category. Okay, so we did a lot of pre-processing there, but we kept a lot of the different columns. So let us go ahead and start dropping all the columns that we already pre-processed into different columns. So combine pd.drop. Drop is looking for the name of the columns to drop. So I'm going to drop name. I'm going to drop age. I'm going to drop ticket. Fare. Ticket count. And fare per ticket. I also need to pass in which axis we're looking at, and that would be axis equals 1. And I need to say in place equals true because I didn't assign it. So again, dropping all of the columns that we no longer need because we've created all these different bin columns or we preprocess in a different column. Display combined PD. Okay. Now you can see we've reduced back down to essentially what we started with, but now they are grouped and it's a little more friendly. So I can actually say, I go back up. I'm going to take where I took all the unique variables, and I'm going to go ahead. I grabbed the wrong function. I can just do it here. N unique, I believe, is the function. Oops, sorry. I can't run this again because I already dropped it. Let me just make a new cell. Okay, now you can see we have new values for our unique or for our columns. So we have in class we have 3 unique columns. Those didn't change. Class and sex didn't change. In number of family we have up to 9 people within the family. We have 5 different bins for the fair, 8 different bins for the age. You can see now we're down to a manageable amount. There's no like 1,000 different unique variables in one of these categories. So now we've pretty much got our data set to a point where we can start feeding it to a machine learning model. There's one more step in order to encode those, but we're going to stop here and pick that up in the next video and actually start looking at our first machine learning model that we're going to apply this to. So thanks for joining me on this video. If you got anything, definitely like it. Subscribe to the channel if you want more stuff like this. And stay tuned for those following videos on how we can start applying some machine learning models to predict whether these people survived or not. Thanks and take care.